So in order to remember how to complete the square, we backed up from there a couple of steps further and just kind of reviewed working with multiplying binomials to produce quadratic trinomials, and then starting with quadratic trinomials to factor them backwards. So just a quick review. I'm multiplying two binomials together. You could certainly just distribute the x through and go back and distribute the 7 through. I'm going to stick with the box method, however, just because we're going to do this process in reverse as we factor. So multiplying an x and a positive 7 times an x and a minus 4 in each of those binomials. So this box is the product of these two things, so that's going to give us x squared, and this bottom box is the product of these two constants, so negative 28. The middle two boxes are formed by doing the variable in this binomial times the constant in that binomial, and then vice versa, the variable times the constants. These are almost always like terms, and we end up adding them together to produce our trinomial. So when we multiply these two binomials together, we get the quadratic trinomial that starts with x to the second, 7x and a minus 4x is a plus 3x, and then a minus 28, okay? All right, number 2, remember this means that we're multiplying a 2x plus 3 times itself. A common mistake is just to square this and square that. You don't distribute the exponent through the sum. It doesn't work like that. So I'll use the box again just for consistency. There are certainly other options, but we're going to multiply the 2x plus 3 and another 2x with a positive 3. Okay, so here 2x times 2x is 4x squared, and the bottom 3 times 3 is 9. Our second degree function and our constant. In these boxes, the 2x times the 3 gives us a 6x and a 6x. So these are going to get added together, right? So we end up with, when we square that, we get the trinomial 4x squared plus 12x plus 9. Okay, this is a perfect square trinomial. What number times itself would give us that? The square root of that is 2x. What's the square root of 9? 3. Remember how to check it. 2x times 3 is 6x. If you double that, sure enough, you get 12x. So it's a perfect square trinomial, which means a binomial was multiplied times exactly itself to produce it. So keep that all in mind, because now we'll go backward. All right, so we want to factor this. So what we're trying to do is we're trying to go in the opposite direction and decide what binomial times itself gave us this. So I'm going to do this a little differently, perhaps, than we did in Algebra 1. I want to approach it with just trial and error, truly doing what we just did up top in reverse. So the 3x squared would fall here, right? And this constant goes in the lower box. What we need to figure out are what are the two things that added together to give us that, right? That's where that middle term comes from. It's the sum of these two boxes. So I'm going to do a little trial and error. I know that in order to get 3x squared, there's really only one way to do that, and that's to multiply a 3x times an x. I'm actually going to use a pencil here now. In order to get negative 24, though, in this bottom box, well, I've got lots of ways that I could do that. Let's just list them. In order to get 24, we could do 1 times 24, 2 times 12, 3 times 8, 4 times 6, and one of these needs to be negative. So of course I could continue with a positive 1 and a negative 24 and so on. So there are 8 different ways to get negative 24. I'm just going to do a little trial and error. But I'm going to cut to the chase. I'm going to try these two, all right? So let me give you a hint. Generally speaking, I would not put the 6 on the same side as the 3 because those numbers are both divisible by 3. I don't want them to have a common factor. So I'm going to try putting the positive 6 up here and the negative 4 here. And let's see what happens when we do that. Negative 4 times x gives us a negative 4x. 3x times 6 gives us an 18x. And sure enough, if we add those two things together, we get that positive 14x. So I didn't do a lot of trial and error, mind you, but I could have. I could have just played around with these numbers until both of these numbers needed to multiply to give us negative 24 until I got something that added up to 14x. At any rate, these are my two binomials. I have a 3x minus 4 times an x plus 6. All right. The next three are perfect square trinomials. Let's just test it really quick. What times itself gives us x squared? X times x. It also ends with a perfect square, 7 times 7. If you multiply those two things together, you get 7x, and if you double that, sure enough, you get 14x. This is going to factor into an x plus 7 times another x plus 7. Or x plus 7 squared. Now, if you didn't recognize that, we could have used the box. In the upper left corner, we had x squared. In the lower right, we had 49. These two boxes need to add to give us 14x. Well, we know we have to do x times x to get x squared. And this one's a little easier than the one I did before. There were kind of lots of options to get 24. There aren't that many ways to get 49. I think 7 times 7 probably pops into mind, right? So x times 7 is 7x and 7x, and sure enough, those two things add up to 14x, so that's how it factors. It was a perfect square trinomial, okay? Let's do this next one with the box, and then I'll remind you how we knew it was a perfect square trinomial, and I don't really need to do this step, but 25x squared goes here, and our constant is last, okay? So I know that these two terms are going to need to add together to give me 20x, but let's start with what I know here. In order to get 25x squared, I could do one of two things. I could do x times 25x, but that's not usually how it factors. It doesn't usually factor with the 1 times 25, so the only other way to get 25x is a 5x times a 5x. Now, let's do some trial and error here. To get 4, I could do 4 times 1. That would work. I get a 25x squared here. 5x times 4 is 20x. 5x times 1 is 5x. But the problem is those two things add to give me 25x, not 20x. So 4 times 1 doesn't work. This is what I meant by trial and error. So what's the other way to get 4? We could also try 2 times 2. If we do that, 5x times 2 is 10x, 5x times 2 is 10x, and sure enough, those add to give us a 20x. So everything checks. I get my 25x squared, my 4, and my 20x. So we know that this factors into a 5x plus 2 times another 5x plus 2. So just 5x plus 2 squared. So remember, we could have tested that. How could I get 25x squared? 5x times 5x. It's a perfect square. So is 4. 2 times 2 would give us 4. 5x times 2 is 10x. And if we double 10x, we do get 20x. So it meets all the conditions for being a perfect square trinomial. All right, let's do this last factoring problem. And I'm going to go about it the same way. I'm going to use the box, okay? So in the box, I know that I have a positive 9x squared and a positive 1. I want these two boxes to add together to give me a negative 6x. So somehow I've got to get a negative into this problem. Well, this certainly has the looks of a perfect square trinomial, doesn't it? That's a perfect square, and so is that. So let's try 3x and 3x. 3x times 3x gives us 9x squared. There's really only one way to get 1, and that's 1 times 1, okay? But 3x times 1 is a positive 3x. 3x times 1 is positive 3x. If we add those two things together, we get 6x, not negative 6x. So we just have to back up a second and realize that there's another way to get positive 1 when we multiply. If we multiply a negative 1 times a negative 1, that would also give us positive 1. And now this 3x is negative, this 3x is negative, and those add together to give us a negative 6x. So it checks out. It also was a perfect square trinomial because I got the same two binomials. So it factors into a 3x minus 1 times another 3x minus 1, or just 3x minus 1 squared. All right, I won't use the box anymore, I'll just factor. All right, so what value of C would give us a perfect square trinomial here? Well, remember, we want to test this. That's a perfect square, y times y. I'm going to multiply that times the square root of whatever this number is, and then whatever this is, we will double to produce that. That's kind of how we check it out. Well, when this starts with a 1, which is what we want, all we have to do is take half of this. Half of negative 8 is negative 4, and square it. Negative 4 squared is 16. Let's see if that works. What's the square root of 16? 4. Y times 4 is 4y. And if we double 4y, we're close, we get 8y, but we don't get a negative 8y, do we? So this would actually need to be a negative 4 times a negative 4, then we would get negative 8y. But the 16 itself is positive. The C is always a positive number, okay? All right, let's do number 8. So this one's a little harder because it doesn't start with a 1. It starts with a 25, obviously, but it is a perfect square. What's the square root of that? 5x. So whatever this number is, we're going to take the square root of it, and then we're going to multiply that times our 5x, and when we double it, we're going to get 10x. Well, what's half of 10x? 5x, right? If we double 5x, we get 10x. 5x times what would give us 5x? That needs to be a 1. 5x times 1 is 5x. And if you go backward and square 1, you could see that that would be a 1. Does that work? The square root of 1 is 1. 1 times 5x is 5x. 5x doubled gives us 10x. So C would need to be 1. C would need to be 16. All right, let's solve by completing the square. Here we go. All right, give myself just a little more room. So finally, this is why we reviewed all of this. Let's complete the square. So right now, this looks like it could possibly be a perfect square trinomial. It starts with a perfect square, and 16 is a perfect square, but negative 16 is not. To get negative 16, you would have to multiply positive 4 times a negative 4. So that's not a perfect square. So what we're going to do is we're going to move C over to the other side and group up our x's. Okay, so I have x squared plus 6x. And in order to move C over, it's a minus 16. I need to add 16 and add 16. So this is equal to 16. Now I'm going to work on making this a perfect square trinomial. So here are my steps, and this is a whole lot easier than probably everything we reviewed. Because this is a 1, all I have to do is take half of this. We saw that when this was a 1, this process was easier. Half of this is 3, and square it. So you take your b, you cut it in half, and you square it. And you can do that anytime the a is equal to 1, as it is here. So that's going to be 9. So I just added 9 randomly to the left side of this equation. So in order for that to be a legal mathematical move, I need to do it to the other side to keep things balanced. Okay, so we get 25 over here. And this is now a perfect square trinomial. X times x gives us x squared. 3 times 3 gives us 9. If you multiply x and 3 together, you get 3x. And if you double that, you get 6x. So this factors into, here's the thing, we created this. We made it a perfect square. So I know it's going to factor like this. So this is all we have to do. What's the square root of x squared? What times itself gives us that? X times x. What times itself gives us 9? 3 times 3. And because this is plus, this needs to be plus. Okay, so there you go. That's how it factors. And then we take the square roots of both sides to undo the squaring. Take the square root on the left. You have to do plus or minus square root on the right. So this wipes out the squaring. It's an inverse operation, and we just get x plus 3 equals a positive or a negative 5. So now, in order to solve for x, we're just going to subtract 3 from both sides. So when we do that, we get that x is either equal to a positive 5 minus 3, which gives us 2, or x is equal to a negative 5 minus 3, and we get negative 8. And those are our two answers solved by completing the square. All right, last one. Same thing. It looks like a perfect square trinomial, but that's not a perfect square. So we're going to move the c over and group up our x's. So we have 4x squared plus 8x, and I'm going to add 5 and add 5, and that's equal to 5. All right. Now I notice that this is not a 1, and this is much easier to make a perfect square trinomial if this is a 1. So we're going to use the distributive property backward. We're going to factor that 4 out. I want it to be a 1x squared. So I also have to divide 4 out of that, so that would leave me with 2x, okay? And that equals 5. All I did was just change the way this was written. I didn't add anything to the problem. I don't have to do anything over here yet. All right, so the next thing we do is go through our steps. Because this is a 1 now, I'm going to take half of b, half of 2 is 1, and square it. 1 squared is 1. That's what I'm going to add. But remember, because this 4 is out here, 4 times 1, I really added 4 to the left side of the equation. So we need to be sure we add 4 to the right side. All right, the 4 is still out there, but this now factors. It's a perfect square trinomial. It's going to factor like that. What times itself gives us x squared? X times x. What times itself gives us 1? 1 times 1. This is a plus, so that's a plus. And this is equal to 9. All right, I'm trying to solve for x. Let me get rid of this 4 out here. I'm going to divide both sides by 4. So we're left with an x plus 1 squared is equal to 9 fourths. Let's go ahead. That's a nice decimal. We can write that as a decimal. X plus 1 squared is equal to 2.25. So now we're going to take the square roots of both sides, remembering to do plus or minus square root on the other side. So out pops the x plus 1, and on the right we get plus or minus 1.5. Okay. All right. So now we just subtract 1 from both sides. All right. So we're going to subtract 1 from the positive 1.5 and the negative 1.5. Okay, so x is equal to a positive 1.5 minus 1, which is just a half, or x is equal to a negative 1.5 minus 1, which is negative 2.5. Okay, all right, so that's just a review of algebra, but in all sincerity, all we really have to be able to do for geometry is this much. We could have essentially stopped kind of right here on both of these problems.